Good to have you back. So here's another lesson. Today we're going to talk about top common mistakes when working with logarithms. Okay, and this is actually very common, and I've seen it throughout the years. So I want to make sure that you go through these. We're going to go through these together so that you don't make the same mistakes. All right, the first one, mixing up the product and quotient law with addition and subtractions. And I see that all the time, that, for example, log of a plus or minus b, some students, they think that that's log of a plus or minus log of b, as in they just multiply log into the a and b bracket, which is not true. So for example, if I give a quick question, log of 10 plus or minus 10, sometimes some students, they say that's log of 10 plus log of 10, which is equal to which is equal to 1 plus 1, which is equal to 2. But that's not true, because bracket has to be working first. So 10 plus 10 has to work on. That means that would be log of either 20 or log of 0. And therefore, that will not be true. So let's fix that the correct way. So log of a plus b is just log of a plus b. You cannot simplify that. You have to deal with the inside, and whatever that is, then you have to figure that out. So in this case, log of 10, let's say 10 plus 10, let's not deal with the minus because that's just negative. Same thing, that would be log of 20. And log of 20, you punch in a calculator and find out what the value is, and definitely is not 2, 100%. Okay, so that's number one. The second one, let's go to the next one. Incorrectly using the power rule. This is very common, by the way, super common. The original law is this: log of x squared base b, that is 2 log of x base b. But if you have these brackets around log of x base b and then to the raise of to some power or exponent, you cannot bring that to the front. That's an illegal operation. That's not a law, okay? You need to leave that be. If this shows up like that, this is just, you're going to treat that as a quadratic log term. That's what that is, okay? So make sure you don't mix them up. All right, number 3, multiplication, division of log being confused. This is so common. It's comedic. I have a lot of sympathy for some of the students, but sometimes they get confused. So log of x times log of y, they say that's log of x times y. Well, you can't do that. That's not a law. There's no such a thing. And so is the division. Now, this thing is true. Log of x times y is equal to log of x plus log of y. That is one of the addition logs or multiplication and division law of logs, and so as the division one, log of x divided by y as an argument, that's log of x minus log of y. Okay, so that's another one. Do not confuse the two. They are not the same. Let me give you an example. Log of 2 times log of 3. That is not equal to log of 2 times 3, which is not equal to it. Okay, there's no such a thing. You got to find out what log of 2 is. Whatever it is, you multiply it by log of 3, and it's guarantee is not log 6. Okay, make sure that is, you know that. All right, let's come up to number 4, ignoring the domain and extraneous root when you solve logarithmic equations. So suppose we have this equation, I set it up here. So this is another example, okay? And when you go ahead and you solve this equation, you will end up getting x equal to 5 and x equal to -2. But if you just leave it like this, you are now being penalized, because these two are not actual solutions to this equation, because one of them, or maybe both of them, they actually won't work in the equation. So especially look at -2 right away. So if you just plug the -2 back for x, log of -2 plus log of -2 minus 3, that's log of -5. Well, you got negative argument for log. That is one of those restrictions that you cannot have, remember, so the rule says for restrictions, if you have log of base b of x, this has solutions only where x is greater than 0. Okay, so though that is the restrictions for x. So if you have x is now negative number, in this case would be negative 2 right here. So this is negative 2. Well, this is x is less than 0. So this is your extraneous root. And if you don't check that, you ignore the domain, this the answers here is not correct for this equation. So make sure you always look at the domain and then find all the extraneous root by checking your answers. You must check your answer, okay? You must check all your answers. Very good. Move on to number 5. Confusing the quotient rule with the change of base rule. That happens quite a bit actually, to be honest. Not as much as the other ones, but this one does happen, especially when it comes to simplification. So when you have a setup like that, you cannot change the base based on what you see in terms of division. So the rule says log of x divided by y is log of, and then let's call it base b, as log of x base b minus log of y base b. That's the rule. Has nothing to do with division. It's a subtraction into logs. Okay, so when you have an argument of x divided by y, then you have to subtract the log terms. All right, next one. This is so common, you will not believe, but it does happen. You may have done it yourself, but it's okay. It's common. In 27 years of teaching, I've seen this many times. Say, students sometimes, I don't know, they feel that, okay, log, log is some kind of a factor, and they just cancel it. They really do. They just go ahead and log goes away, but log and becomes 20 over 10, and the answer will be 2. And sometimes what they do, they actually say, okay, log of 20 divided by log of 10. They say, oh, that's log of 20 divided by log of 10. So just 20 divided by 10 as 2. So that's log of 2. So that's also incorrect, right? So both of these are incorrect. Make sure you know how to do that. So again, log of 20 divided by log of 10, there's nothing you can do about that. You have to find out what log of 20 is, and once you get log of 20, whatever the value is, you divide it by log of 10, and that would be your answer. Okay, not dividing the 20 by 10 and then becomes 2 or log of 2. None of that. Okay, so you have to actually deal with log of 20 and then deal with log of 10 and divide them. Do not cancel the log, L-O-G. Okay, don't do that. No, no, no. All right, number 7. Dividing log terms equal to subtraction of logs. So log of A divided by log of B, same item number 6 to avoid. So log of A divided by log of B, some students, they decide to say, well, that's just log of A minus log of B. They forget that the law of that is log of A divided by B. The argument is being divided, not the entire log, okay? So this is true. This is log of A minus log of B, but not like that. So this is not true, and please do not mix them up. This is not true at all, okay? So make sure. Number 8, multiplying logs. This is another common one. Log of x times log of x. Some people decide that this is log of x squared. So they just multiply the x and x and it becomes log of x squared. There's no such a law. So the answer to this one is log of, let me rewrite it. Log of x times log of x is actually log of x squared. There are two of them. Okay. That's all it is. It's just like basically, what if this was y and this was y? What is y times y? Well, that's y squared. Same idea. Okay, there is no law, log law that does this. So you just have to multiply the entire thing and same base and add the exponents, and you got two of them. So it would be log of x in bracket to the exponent 2. So number 9 is not condensing the log terms. before converting to exponential form. I wrote an example here for you. So suppose you have a log of x base 2 plus log of 3 base 2 equal to 4. I've seen this type of mistakes all the time. And the students, what they do, they say, okay, well, this is true. So 2 to the 4 is right there. So I'm going to change it to exponential form. But then I'm going to just write down x plus 3. So x plus 3 equal to 2 to the 4. And then they go ahead and solve. Well, that's not true. You cannot do this. This is a illegal operation because you must have both log terms condensed in as one. So to do this, you have to use this addition. So that becomes log of x. So it would be log of x times 3 base 2 equals to 4. And basically, this is log 3x. Okay, so now that you have that, you get 2 to the 4 is equal to 3x. And then from this point on, you go ahead and you solve, divide both sides by 3, basically in this case, and you solve for x. But you cannot do this without going through putting the two log terms and condensing it into one term and then changing the form to exponential form. All right, 9 of them. All right, all of these are useful, common mistakes. Now I hope you don't make them anymore. Fantastic. Glad that you stayed with me until the end. Hope it was useful. Check out the next video in logs and exponential functions and equations and simplifications. Until next time, keep at it.